Welcome to VINDAL'S Concepts and Mass Physics. Today, we want to talk about physics, and I want to treat this misconception about electric field. And according to this young man, the man called Coulomb's law, Coulomb says that the force of attraction between two charges maybe Q1, I can call this one Q1 and this is Q2, that the force of attraction holding these two together, or repulsion, the force of attraction or repulsion between two charges is directly proportional to the product of the charges and inversely proportional to the distance separating them, or to the square of the distance separating them. So it's going to be R squared. Therefore, and that K is the constant, most times called just constant of electric field. I don't want to add more to it. Where the constant is, where the K is given as 9 times 10 raised to the power 9 units. Okay. Now, at this case, there is something about this force. This force you are seeing now is not just one. You know, sometimes when we look at electric field, plus, these are the two charges that are repulsing against each other, because positive will repulse. There will be a repulsion between positive and positive. Now, one thing you must know is that this force, this one is F1 on 2. Why this force is F2 on 1? That's what I'm saying, is that the force that this charge is feeling is based on the force this one is mounting on it. So this Q2 is feeling a force because of this charge Q1. Why this charge Q1 is feeling a force because of this charge Q2. And according to Newton's law, you know, he's an Englishman, and according to Newton's third law, they say that the force, that in every action there is equal and opposite reaction. Therefore, the force of charge 1 on charge 2 is equal to negative of charge 2 on 1. Therefore, the force here and the force here are the same, but they are working in opposite direction. The same thing happens here. The distance separating them, the force of this one on this particular body is this place, which is, let's call this one Q1 and this is Q2, is F1 on 2, is the force pushing it this way because they are opposite charges. This particular force, this particular charge will be pulling this one towards him, and with the force F1 on 2 is going to be equal to minus of the force that this one is feeling because of this one, whereby this particular one will be drawing Q1 with this force F2 on 1, and that is F2 on 1. So the force is not just one, like we know that this is just the one we used to see. It's not just one. When the two charges are involved, it's not just a force that they feel. Rather, there are two forces according to the charges on them and according to this illustration. And I'm going to use this to answer many other questions. So I will call this one part 1.